How does this work?
Hmm?
After we sign in with the game pin, what do I do?
You're already here.
Yeah, but like, what do I do?
Okay,
Like, how does
so
Kahoot
I'm
work?
waiting for everyone to join in, and then it's more so we're gonna answer like 22 questions. You'll once I start the game, you'll see the choices and you can just click.
Oh,
Have you never played Kahoot before? Like not at all in high school or anything?
no.
I know I played it once before here.
It was the day that the power outages were out and
Oh yeah,
that
yeah.
I couldn't be.
This is like the only thing I did in high school.
Yeah, this was like one of the highlights of high school.
Hence why I do it. So who am I missing? Am I missing someone? One, two, three, four, five, six, seven, 8, 9, 10, 11, 12, 13, 14, 15. Okay, who named themselves mitosis? I'm missing like 2 people. Unless I completely missed something. Who am I missing? Gabby, you disappeared. Where'd you go? No.
Oh, sorry. Hold on. My phone turned off. Okay, sorry. I should be back. There you go.
Okay. Who else am I missing? Oh, perfect. We're all set. Did I mute? Which of the following is not a type of enzyme in gene expression regulation? So which one of the choices is these, guys? Good. Yes, good. It is helicase. Helicase is involved in? What's it involved in?
Is it like
Winding and unwinding DNA?
Yep, unwinding DNA. Good job. What do inducible enzymes do when a specific substrate or nutrient is present? Good. It induces, right? So when you think inducible, think induce. So it sets off whatever is happening, right? It's inducing or stimulating the expression. What do repressible enzymes do when a specific substrate or nutrient is present?
So you can't undo an answer, it seems.
Good. So repressible, think repress, right? Because you have that, right? Good work. Ooh, some competition going on here. I like it. Constitutive enzymes are enzymes that are continuously produced regardless of the chemical makeup of the environment. Is it true? Is it false? Yep, it's true. So constitutive, think continuous, okay? So it's just going on its own business, doesn't really care about what's going on in the environment. It's like, okay, whatever. Like, we need to get things done, so doesn't matter what's around us, we just keep on pushing forward. That's what constitutive enzymes do. Okay. What type of control is involved when transcription occurs unless it is shut off by a regulator protein? Oh, okay, split down the middle. Okay, so negative controls is when a protein, a regulator protein comes in and it's like, no, no more, stop, don't do it, right? Whereas positive controls end up inducing, or a molecule comes in and it kind of like, okay, buddy, come on, let's do this. Come on, wake up. We're like, okay, let's get you started here, right? Does that make sense? Why that's negative control?
Yeah, absolutely.
Okay. What type of control is involved when transcription occurs when a regulator molecule directly stimulates it? Yay! Everybody got it right. So, but does that make sense what the difference between positive and negative controls are in gene expression? Because it can take on a whole different meaning when it comes to experiments and other stuff. So this is what that is in this context.
Yeah, makes
Okay.
sense.
What is a functioning unit of genomic DNA containing a cluster of genes under the control of a single promoter. Good. It is an operon. Okay, guys, it is not a promoter because it's a promoter with a bunch of genes under the control of one promoter, right? So that's what's called an operon. So you have a promoter and a bunch of genes. Can be more than two, right? So that's the definition for operon. It is a functioning unit of genomic DNA that contains a cluster of genes under the control of one promoter. So you know how we always said a gene has a like a promoter going on, right? So every gene with a promoter gene, UTR, untranslated regions, all that fun stuff, right? In this case, we have a promoter, gene, and then where it terminates everything, right? Does that make sense? What an operon is?
Yeah.
Which of the following is not a structural gene within the last operon? Yep. So what do you guys know about the lock operon? What does it do? So this answer is correct. This is not one of the structural genes. The other three are structural genes of the lac operon. But what does the lac operon do?
Breaks down lactose.
Wait, say that again.
Does it break down lactose?
So the lac operon is involved in participate in the processing of lactose. So do you guys know what the three of these guys do? Like beta galactosidase, transenacetylase, permease, all the three wonderful stuff. No? Okay. So beta galactosidase or LAC-Z, it's just producing an enzyme called, so beta galactosidase is an enzyme that is produced from the gene LAC-Z. And this enzyme is the one that cuts up lactose at, so there's a bond in the lactose called beta galactoside. This guy comes in, cleaves it, and generates glucose and galactose. And sometimes in minor cases, you have allolactose as well, but that's in like a little side reaction going on. Then you have LAC-Y. So the LAC-Y gene produces an enzyme called permease. Permease here ends up transporting the lactose into the cell. Okay, so that's permease, what permease is up to, which comes out of LAC-Y. Then you have LAC-A. LAC-A gives out an enzyme called transacetylase. So transacetylase ends up detoxifying or removing any toxic byproducts, okay? So does that make sense with those three structural genes? Yes, no, maybe so. I promise there's another video up on this in regards to prokaryotic gene regulation on Blackboard. But does that make sense so far?
Yeah.
Okay, good, 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 good. Hey, where did this come? Okay. Attenuation involves termination of mRNA synthesis. True or false? Whoa, okay. So attenuation is essentially terminating the mRNA synthesis. That is what's happening when something is being attenuated. So true is the answer for that one. Okay. Attenuation of the trip operon functions by controlling. If anyone says translational, I'll cry. Ooh, okay. So we know attenuation involves terminating the mRNA sequence, right? Synthesis. So this is the answer to that. It is, so attenuation is essentially at the termination point. It's not completely blocking the transcription initiation. Like it's allowing transcription to occur, but it's involved with the termination portion of transcription. Does that make sense?
Yeah.
Okay. Okay. So, which term most appropriately refers to a regulatory protein in prokaryotes? Okay, so helicase activation has nothing to do with regulations. It's not a regulatory protein. Helicase is unwinding the DNA when it comes time for replication. Okay? I'm happy that nobody put translator. Yeah, guys, so remember RNA processing is not in prokaryotes. RNA processing is in eukaryotes, and it is a term that refers to the 5' and 3' cappings and the splicing events in eukaryotes, okay? So if that ever comes up again, don't do it. If it's talking about regulation. The bulk of DNA replication in E. coli is carried out by ooh, okay. We're thinking about the wrong polymerase. Okay. So DNA polymerase 2 is not really involved in this one. It's more on DNA polymerase 3. That's like taking over elongation, and it's like going through the DNA itself. DNA polymerase comes in mostly for like break repairs or other things. Does that make sense?
Yeah.
No, no. To replicate a single-stranded circular DNA molecule, which enzyme is required besides DNA polymerase 3? Yep, it is primase. Do you guys understand why it's just primase?
I don't know if we've gotten to this part of lecture yet.
Okay, so helicase only comes in if you have a double-stranded DNA where it's wound up together, right? Ligase only comes in when you have nicks like that come in with. In another one of my questions, I have a diagram that shows it more clearly. But ligase comes in when you have different little, so they're going to be called Okazaki fragments. It's part of the lagging strand, which is the strand that is at 3' to 5' instead of the. So those guys come in, they kind of repair any breaks in the double-stranded DNA. So these guys are involved with double-stranded DNA. Does that make sense?
Yeah.
Okay. Which enzyme is responsible for unzipping the double DNA helix? Okay, so majority wins here. It is helicase. So it's either unwinding or unzipping. That's what helicase does. Ligase, as I said, it's joining or repairing any nicks in the DNA strand, okay? So. Which enzyme can attach together strands of DNA without double strand breaks? Oh, okay. Primates, guys, primates only makes primers to prime off the initiation spot for replication, right? So for DNA polymerase to start off, it gives something to work with, you know? Can't just start out of thin air. Okay, who put helicase? No. But yes, that is what ligase does, okay? So break is repairing double strand breaks. Which is the DNA strand that DNA polymerase constructs in the 5' to 3' direction? Oh. Okay, so I know it can be a little confusing with this sentence because obviously DNA polymerase only works from 5' to 3', but in this question it was asking more on the side of so the leading strand is correct, and that's because it's going directly. When it starts, it has no stops, no breaks, no nothing. Whereas with the lagging strand or the discontinuous strand, these are pretty much synonymous with each other in this context. It's lagging because since the other strand is going from 3' to 5' while the other strand is just going, the other polymerase has to be like, okay, so we have to have a primer here, then come back, then go back again, another few nucleotides, start a primer there, continue on there, and then making the nucleotide chain, right? So it's making more fragments. Those fragments are in a discontinuous manner because once the primers are out, they have a little bit of gaps going on there, right? So they have to get rid of that, and then ligase comes in and they join them together. Does that make sense?
Yeah, it does.
Okay, good, good. Because I don't want to confuse the crap out of you guys with this. Yay. DNA polymerases add new nucleotides to which end of the growing DNA strand? Ooh. Okay. So, okay. So it is actually connecting to the 3' end, right? So when your chain is growing, the next nucleotide comes and gets attached to what part of the previous nucleotide? The 3', right? We're not putting 2 5' together, right? Does that make sense?
I knew I pressed it wrong right after I pressed it.
Huh?
I knew I pressed the wrong answer right after I hit it.
Ah, boo. But does that make sense though? Why it's 3'?
Yeah.
Okay. The enzyme required only for the replication of ends of eukaryotic chromosomes is oh, okay. So what are the ends of a eukaryotic chromosome called? What is that end little thing called?
Is it called a telomere or
Yes.
telo? Okay.
So telomeres are the ends of eukaryotic chromosomes. So one of the things about replication is that that's kind of where the so at the very end is where they put the primers, right? So they have no room to put any other primers after that. So it's like, okay, how can we and losing this telomeres can cause different age issues, like it's kind of like with aging and all that fun stuff. So you don't want to lose all of these telomeres until you're like ancient. Okay. So what eukaryotic cells do is that they have this little buddy, their little enzyme buddy called telomerase. They come in and they're like, okay, let's make sure the telomeres are all happy, looking handsome, just making sure they're all there, they're copied and they replicate the telomeres. Does that make sense?
Yeah.
Okay. Yeah. What is the central dogma of molecular biology? What? Who put DNA is everything? Okay, so guys, don't forget it. DNA to RNA to protein, okay? That's like the basic version of the central dogma of molecular biology. If you guys don't remember anything from this class, at least remember that. Or I'm gonna have very upset upper level biolab TAs be like, why? So don't get me in trouble with them, okay? So that's the answer. RNAi attacks diseases caused by overexpression of a specific gene or normal expression of abnormal gene products. So did Dr. Osuna cover RNAi in class?
If you did, I missed it.
Yeah, he did.
Okay, because I know he had like 9 slides in chapter 18, I think. Is it chapter 18?
I don't know.
I
It's
think
pretty.
so.
It's pretty easy to miss. He like rushes through his slides.
Yeah, okay. So make sure you guys watch that stuff. This next exam, in my opinion, will probably be more conceptual than anything. So make sure to look into that. I'll put up another video that explains RNAi. That way you guys can just look at that and be like, ah, okay. But essentially, RNAi is to interfere with the RNA or like degrade the RNA that is produced out of these like overexpressions or any abnormal genes, like any transcription products that come out, they're going to be attacked and be like, no, 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 no. And they're like karate chopping everything. Okay. That's like the simplified version of what RNAi would be doing. There's a lot more details that needs to be covered in that. Okay. So make sure to watch Dr. Osuna's video and I will put up something that can at least help you guys look into that. Okay. Okay, so DNA replication is what kind of oh. Okay, so semi-conservative is correct. What do you guys know about semi-conservative? Like, what does that mean to you guys?
That for the most part, it transcripts DNA right or translates, but there's mutations and errors.
Okay, so when it's saying semi-conservative here is saying that it keeps a parent strand and a new strand together. Does that make sense?
Oh,
So full conservative is saying that parent strands together, new molecule strands together, no touching between them, which is not the case when we look at this diagram, right? So in this case, you have a parent strand and a new strand, parent strand and a new strand. So this is what I was talking about earlier when we were talking about Okazaki fragments. So we have a primer come in around the 5' side, it adds on, and then another one comes in, adds on. like kind of going on there. Does that make sense? So those guys would be Okazaki fragments. These primers gets rid of them, and then you end up with ligase coming in to join them together. Does that make sense?
Yeah.
Okay. Wonderful, wonderful, wonderful. Let's go to the next question. What does DNA replication mean? Beautiful. That's good. Yes. Okay. So replication is essentially making copies of DNA. So DNA replication, it is making copies of DNA strands. Okay. Yay. Woohoo. Great job, guys. Great job. Okay. So do you guys have any questions, concerns? Did you guys enjoy this?
Yeah, it's a fun game. It's difficult, but it's good.
Yeah. Feel like I might do this more often if it's online again. That way I know what everyone's thinking. If you guys are already done with this guy, you guys are free to leave unless you guys have any questions, concerns, comments.
Thank you.
Absolutely. Thank you.
Thank you.
Not a problem.
Thank you.
Last Zoom session, isn't it? Nimi,
Yep.
it's our last Zoom session, isn't it?
Mm-hmm.
All right. Well, happy holidays.
You too.